Okay, students. Sorry it took me so long to get this camera adjusted. So I had to cut it off and try it again here. So one of the things I didn't cover last time was quadratic equations. And the equation that I'm going to solve for you is this one here. 13x squared minus 2x minus 8 equals 0. So this one here, you can't really factor and solve that way using the FOIL method, but we can use the quadratic equation and we have to identify what A, B, and C is. So this is A, that's the coefficient A, and this is coefficient B here, and C, okay? And I don't know if you remember this equation or not, but here's the equation. Negative b plus or minus the square root of b squared minus 4ac all over. Hope you can see that okay. Over 2a. Okay. So negative b plus or minus the square root b squared minus 4ac over 2a. So we're just going to do a substitution here. So we have negative and negative 2 plus or minus the square root of negative 2 squared minus 4 times a is 13 times c is negative 8 all over. So I hope you can see that. That's not very clear. Maybe that's a little bit better. All over 2a, so 2 times 13. All right, so I plugged this in the calculator earlier. And please check my math because, you know, Mr. Morris is not perfect. I make lots of mistakes. So the value of x that we're looking for, again, this is the value of x. I should say the roots, right? So x equals, so a negative negative 2 is 2 plus or minus. When I did the math here, I got, you can check this, 20.49 all over 26. Okay. And then when you solve for this, I got x equals 0.86. Okay. All right. So again, that's the review of the quadratic equation. You plug in your coefficients into the quadratic formula and solve for your roots. Okay. Okay. So that is the quadratic equation. Now we are going to go into chapter 2. All right. So let me turn the page here. All right. So we are talking about the field or the branch of mechanics. And as you're working on your mechanical engineering technology degree, right now you're taking statics, okay, and eventually you'll take dynamics, And then you'll take, I'm sorry about that light casting the shadow. I hope you can see this okay. Statics, dynamics, and strength of materials. Okay. Now, let's go over some definitions here. So here are some definitions. Just a few basic definitions we need to cover. Okay. So statics is the study of forces on rigid bodies at rest or at constant velocity. So statics is the study of forces on rigid bodies at rest or at constant velocity. So now let's review what dynamics is. I know this is not the dynamics course, but you need to understand how statics is important as a prerequisite for dynamics. Dynamics is the study of forces in motion. And one law that you'll learn in dynamics is very important is the sum of the forces is equal to mass times acceleration. That's Newton's second law. Again, we're going to worry about that in the future. For statics, though, I forgot to say the sum of the forces equals 0. Everything is in equilibrium. It's not really moving. If it is, it's at constant velocity. Constant velocity means you have no acceleration. So acceleration would be 0 here. So again, your force is equal to 0. And then of course, the last definition here is strength of materials. Okay, so in mechanics, strength of materials, again, the strength of materials is its ability, I should say the material's ability to withstand an applied load without failure. Or plastic deformation. Again, as an engineer, we're concerned about whether or not it's going to fail, whether something is going to fail. So yes, things do fail. As an engineer, we want to prevent that. And later on, we'll understand what the term plastic means. So we'll say that for strength of materials. But the main definition for this class is statics is the study of forces on rigid bodies at rest or at constant velocity. Okay. All right. So we're going to move on to another topic in regards to statics, and that is what is a scalar quantity and what is a vector. Some of y'all may have learned these terms already, perhaps in a physics course. So let's talk about a scalar. You know, what is a scalar or scalar quantity? So we'll say scalar quantity here. Okay. Let's say physical quantity described completely by its magnitude. Completely by its magnitude. When you hear the term magnitude, you're referring to its size. Okay. Here's some examples of scalars. Okay, so volume. Volume is a scalar quantity. You know, it's perhaps in feet cubed or inches cubed, perhaps. All right, and then you have density, which is the mass per unit volume. So mass divided by volume. Okay, and then you have speed. Okay, speed is a scalar quantity, miles per hour, for example. I'll put miles per hour here. Or you'll probably see it written like this, miles per hour. I hope you can read my chicken scratch. All right, and then energy. And we said mass. Usually like kilograms, for example. And then we have time, seconds. Now, a scalar has magnitude only. If you can remember that, scalar has magnitude only, and that is referring to size, usually. So what is a vector? Which is very important for statics. Okay, what is a vector quantity? I don't know if I spelled that right. Q-U-A-N-T-I-T-Y. I meant to put there. So a vector quantity has magnitude, again, the size, and direction. And direction. So a vector quantity has magnitude and direction. So examples of a vector quantity, examples here. Again, I apologize for the shadow here. Examples would include displacement, okay. We also have velocity, acceleration, position, force, and torque. All right, so these are some examples of a vector quantity: displacement, velocity, acceleration, position, force, and torque. So let's look at a vector. What does a vector look like? There you go. Let's say you have a vector. It looks like this. A lot of times you'll see a vector labeled like this. A little, we call that a little hat. Okay. That defines the vector A. And let's say we have a little vector B here. Okay. So we have vectors A and B. Notice that they have the same direction, right? They're pointing this, they're parallel. So they have the same direction, but they have a what? A different magnitude. Okay, same direction, different magnitude. All right, let's do this again. A, and then we have B. Now these are not parallel. If you extend them, they would intersect. So these have different direction. And also they have a different magnitude. They're not the same size. Now you could do it to scale. You could take a ruler and you could actually draw these to scale if you wanted to, but they're not the same size. Now the last scenario is, again, we have a vector A, and let's say have vector B. In this case, we have same direction and same magnitude. So they're essentially the same size. Now you could get some graph paper and you could draw these to scale if you want to. Okay. All right, so let's talk about adding and subtracting vectors here just for a minute. So adding and subtracting vectors. So let's say you have vector A. By the way, you might also sometimes see it written like this. That's a little confusing, but you might see a hat. Again, that's the little symbol above the letter. Indicate this is vector A plus a horizontal vector B here. And if you want to add those together, the way you do it is you do it several ways. One is called tip to tail. Tip to tail. You take the tail of one vector and you add it to the tip of the other. So for example, if we take vector A like this, and then we add vector B, and we want to know the resultant of adding these two vectors together, this is what we have. This is the resultant vector. So R is the resultant. If you drew these to scale in the right direction, you can measure that and determine by using the scale, how big, what's the magnitude of the resultant. Now, you could do this the other way. I mean, you could just as easily, I said, here's B, right? And you add A to it. And guess what? There's our resultant. Notice the distance here is the same as the distance here. That's the resultant vector. Okay. So the way you would write this would be A plus B. Okay. A plus B. Here be B plus A. Get the same result. So what if you subtract these? So what if you, for example, what does it mean by a negative vector? So if this is vector, let's say this is vector A, for example, right? Then the negative of that would be this. This would be A, and this would be negative A here. Let's look at the one I did earlier. The example I did earlier made a perfect right triangle. What if I had a vector like this? Right? And then plus, you know, it could be another horizontal vector. This is at an angle. And I'm going to add these together. So it's going to be A, like this. And then you, again, tip the tail. You're going to add vector B. And this is your resultant. That's the resultant vector. Okay. So that's adding vectors. And if you were to subtract it, you just use opposites. We're going to do example in a minute where we subtract. Let's do one more addition. This is several vectors. You got vector A plus B plus C plus D. Again, I apologize. I'm not talking too loud. I've been having lots of trouble with my throat. This weather has been doing a number on me. So we're going to add these up. So we got A, right? So we're going to take A. Here's A plus B, tip to tail, right? Again, you want to keep these to scale. And then C, right? And then you come down this way. That's going to be vector D. And your resultant vector would be here. That's your resultant vector. Let's see if we can zoom in. Okay. One more time. This is vector A right here. And then vector B. And then vector. Notice it has to be the same direction and the same magnitude. And we have one coming down this way. Sorry, that went through the label there. And then this is from this point to this point is your resultant vector when you add all those up. All right, let's look at some other examples. So, like I said earlier, if this is B, that's vector B, then this is going to be a negative B. It's going in the opposite, and let's say this is A. So if we add these, you're going to go A, B, and then there's your resultant there, right? But if you subtract them, you're going to have A, and this is your resultant right there. Okay. And this resultant is A plus B, and this resultant is A minus B. Okay. This is opposite direction. Same magnitude, same size, it's opposite direction, right? Okay. All right. There was a problem in your textbook that I wanted to work. I don't remember the number, but this is the problem. So And it wants us to find, you know, the magnitude of A. Hang on just 1 second. Let me see if I can find the number of this problem in your book. I know it's in chapter 1. I should have written this down. I didn't. So this is problem pages turned over here. Problem 1-26. And they give you this is 40 degrees, and they give you this as 60 degrees, and they say that this is 50 inches here. So that's 50, sorry, that's a 50 inches. So 50 inches right there. And it wants to know what A is. When you first look at that, it almost looks like, well, we don't have enough information here to solve it. But we do, because knowing geometry, no, this is a 40-degree angle right here, correct? This is 40. And this angle here is 60. Well, if this is 60, then this angle here is 180, right? These two angles added together. So this is going to be, this angle right here actually is 120 degrees. This little angle right here. Now, if this is 120 and this is 40, that's 160. And that means this angle up here is 20 degrees right there. Because remember, in a triangle, so in a triangle, all the angles must equal 180 degrees. So we learn, you know, the sine law. Well, this is review for those who are not familiar with the sine law. Hang on just a second, folks. So we're going to have a sine of some angle. Since that's a capital A, I'm going to use, I'm going to use the uppercase letters. I know that's going to be confusing for the angles. And then the lowercase letters equal to the sides. So sine A, sine capital A over lowercase a equals sine B over angle, excuse me, sine of the angle B over the opposite side, and then sine C. Let me go over this with you, okay? So this is the angle right here. So you have three angles. And this is the side opposite the angle. So let's use this angle here to represent angle A, all right? And so we're going to have sine 20 degrees. And then the length of the opposite side from here to here, that's the opposite side of 20. So that's going to be 50 inches, all right, equals, now we have this angle here, sine 120 degrees over B. So I'm going to go ahead and change this, if you don't mind, to B right here. And I call that A. I'm just going to call that, I know the book calls it A. Now, we need to solve for B right here. We need to solve for B. So again, there's 20. There's the angle 20 over the opposite side, which is 50. equals the sine of 120. So there's your angle, and there's the opposite side, which we don't know. We're looking for it. We're going to call that B. We can rewrite this equation now. B is going to equal what? 50 sine 120 degrees divided by the sine of 20. So I just rewrote the equation, and therefore B equals what? Let's punch this in my calculator here. This is my phone calculator, so it's not my favorite one to use, but it's going to work in this case. So we got 120 sine times 50 equals that divided by 20 sine equals, and I'm getting B is 126.6 inches. We're going to round this up to 127 inches as is equal to B. And again, you should get in the habit of boxing this in your final answer. Hope you can see that okay. All right, so that's problem 1-26. Now we are in chapter 2. I meant to do this problem actually in chapter 1, but we're in chapter 2 now. We're talking about vectors, right? So there you go. This is, we've talked about a vector. Remember, a vector has magnitude and direction. So problem 2-2A. So we have have 58 pounds that way. Now, there's a couple ways you can do this to add these vectors. You could, by the parallelogram method, you could do this. We haven't really talked about this, but this is another way you can get the resultant vector R. Or you can go back to the tip and tail method here. We talked about earlier, tip to tail. This is 16 and come down with 58. And here you go. This is R. Now you're pretty good. I'm sure you're pretty good mathematicians. Maybe you know, remember the Pythagorean, right? Pythagorean theorem here. And you have two sides to your right. This is a right triangle. So we have a squared plus b squared equals c squared. But this time we're going to use r to replace c. So a squared plus b squared equals r squared. All right. And we got one leg of our triangle 16 squared plus the other leg is 58 squared. And we're going to take the square root of both sides. And we do, we're going to get R equals 60. I'm going to check this on my calculator. I did this earlier, but 60.21 pounds. Let me just check that to confirm it. All right, here we go. We're going to have 16 squared plus 58 squared equals, yes, this is correct. Now we also want to know, what this angle is right here. What that angle is. Because remember, you need to know the magnitude, which we have, and the direction. So the angle is going to give us the direction of the resultant, right? So we're going to use, we have the adjacent leg to the angle and the opposite leg. So we're going to use tangent function. So remember, tangent of some angle theta is equal to opposite over adjacent, all right? And that's equal to, in this case, the opposite leg is 58 over 16, okay? So therefore, theta is equal to the inverse tangent of 58 divided by 16. Let me check it with my calculator. I've already worked it earlier. I'm just double checking though. 58 divided by 16 equals 3.625. And the second function, inverse tangent. Oops, sorry. And I get theta equals 74.6 degrees. And that is that angle right here. That's that angle theta, 74.6. Okay. Now I'm going to work another problem in your book. It's sorry, you may have to watch this video a couple of times, maybe not. But I apologize if you don't see everything. It's not easy to do it this way. But you're not here to ask me questions, so if for some reason you don't see something, I don't see it myself. I'm not reminded that you can't see it. So I may not notice that you can't see it. All right. So look at problem 2.7. And I'm going to draw, eventually you're going to learn what a free body diagram is, but I'm going to draw a free body diagram of that problem. And this is point A. This is 70 degrees. We have something that looks like you have a vector. Here's a vector or a force, right? Which is 20 degrees here. And we know that this is force of 250 newtons. So Newton is SI unit for force. Where pounds is English, newtons is SI units for force. This is point B. All right, it looks like I have everything here. Okay, so what we're going to do here is I'm going to use the parallelogram method here, and I'm going to make a parallelogram out of those two vectors, and the resultant will be this. Okay, that's the resultant vector. So if this is 250 newtons, so is this over here. This is also 250. And so we know two sides of this right triangle here. Let's see. And I forgot to tell you that this force here is 1,500 newtons. So this is 1,500 newtons right here. And this is 250 newtons. We have to find the resultant. So if you can see this, it's a right triangle. Okay, it's a right triangle. And we're going to use the Pythagorean theorem here. So a squared plus b squared equals r squared. And we got 250 squared plus 1,500 squared equals r. We're going to take the square root of both sides. Okay. And when I did the math earlier, I got 1,520 newtons equals r. Now, in the back of your book, they have they call this one. They divide by 1,000. 1.52 kilonewtons is equal to the resultant. So again, you're just using the Pythagorean theorem here. Again, you got a right triangle, right? 1500 this way and 250 this way. And we need to know what this angle is right here. We need to know what that angle is. I'll call it theta. And again, we're going to use the tangent function. So tangent of theta equals opposite of hypotenuse. And the opposite side is 250, right? 250 divided by 1500. So inverse tangent of that expression, 250 over 1500, inverse tangent of that, and you're going to get, let me check with my calc. I got 9.46 earlier. But let me just check that. Double check it. Make sure. So 250 divided by 1500, inverse tangent, and theta is 9.46 degrees. If you add that to the 20, though, what we want to know is what we want to know here is what is this angle from the horizontal. That's going to give us the direction of this resultant right here. This is the resultant vector. Right here is the resultant. So what is the angle from the horizontal? So you have to add that. You have to add the 20 to that. So this is going to be that. We'll call that theta prime. And that's going to equal the total angle, which is 29 point. We'll round this up 29.5 degrees. And the way you'll see it in the book is you'll see the answer. It'll look like this. And this will be 29.5 degrees. Okay. All right. Now I want to work problem. We're moving right along. I'm going to work problem 2-12. Problem 2-12 from your textbook. And I'm just going to double check something here. Okay, yes. So we have this block that's being acted upon by two forces here and here. This angle here is 18 degrees. Double check that. Yes, that's 18. And they give us, again, they're using the parallelogram method to get the resultant here. And they say that this is a 20-pound force. So the 20-pound force applied to the block here, and then there's a 15-pound force being applied here. But we want to know the resultant of those two forces. And it also gives us this angle here of 80 degrees. Okay. So let's see, I think we have it all. And it wants to know what this resultant vector is. And we're going to use, in this case, the law of cosine. We haven't used that yet, but talked about it in chapter 1, or I didn't, but if you read your book, it did go over the law of cosines. There's some problems that I worked out using the law of cosine. And here's the formula: c squared equals a squared plus b squared minus 2ab cosine of the included angle. So this is Any one of these can be A. So we'll say 20. So that's one vector, 20 pounds, plus the other vector, which is 15 pounds, minus 2 times 20 times 15, and then cosine of the angle between those two vectors. So it's a cosine of 80 degrees. Now this is a capital C, which in this case is going to be R. Okay, this is really the R. Oh, excuse me, it's really the, sorry. It's not R, it's the angle. Hang on just a minute. That's our angle here. Okay, sorry. I don't know why I said that was R. That is not R. This is the value of R we're looking for here. So really getting my C's mixed up. This is R. This is that resultant there that we're looking for. So when you do the math here, you want 400 plus 15 squared is 225 minus, when I did the math here, I got 104.2. And so so this is equal to C squared. And so you get C squared is equal to the square root of 520.8. And therefore, the resultant is going to be 22.8 pounds. Now let me check that real quick. Again, sorry, I getting a little tired here, I guess, but A is one leg or one vector. This is, we'll call this A. A equals 20, and this is equal to B. So you have 20 plus, and then notice the angle between the two. That's important. You have to have those. Okay. You have to have that angle rather. So you get 2 times 20 times 15 cosine of 80 degrees, and you just plug it in, and that's going to be your resultant here. So C is really equal to R. That's what we were looking for. Okay. All right. The next problem I want to look at is, I need to slow this down a little bit. Sorry, I'm going kind of fast. I don't mean to, but when you're not here to talk to me, it's a little difficult. So this is problem 2-14. And they have this a vector here of 400 pounds. Okay, and then we have a vector coming this way, and that's 150 pounds. And this is 60 degrees, and this is 80 degrees. All right, so let's see how this goes here. So I'm gonna come here, and this is 400 pounds. And I'm gonna use the parallelogram here to do this, to find the resultant. This is the resultant R when you add those two vectors together. And we have some information here. If I just kind of put a dashed line, remember now, if I continued on with this line of action here, if you have 80 and then you have 60, that's 140, then this angle here would be 40 degrees right there. So if that's 40 degrees right there, then it's 40 degrees right here. Okay. And that means if that angle is 40 degrees, so is this one, because this is parallel to this. So that's not 400, but that's 40 degrees. This is 40 degrees. All right. Now, we need to find some other information here. Again, this is 400 pounds. This would be 400 pounds here. And this is 150. Okay. So we have two sides here and an angle. See, we have this side here, which is 150, and we have this side here, which is 400, and we have the angle between the two, like before. And, okay, so we know that this is the law of cosine. We're going to have to use the law of sines and cosines in this problem. We have c squared equals a squared plus b squared minus 2ac, and then the cosine of the big angle. Okay. So c squared equals it doesn't matter. So we'll use 150 for A plus 400 B minus 2 times 150 times 400. And then we're going to do the cosine of the angle between them, which is 40 degrees. Okay. Now, like I said earlier, C is really the resultant. So when you do the math and take the square root of both sides, you're going to get C, which equals R, equals 301 pounds. Okay, 301 pounds is the resultant. All right, 301 pounds is the resultant. Now, we need to know what these other angles here. I'll call this alpha here, and I'll call this, I did it to myself again, we'll call this angle beta down here, beta. That's this angle here. Sorry, I had the R there and it's kind of blocking the area for the angle. So we're going to use the law of sines here. We're going to get the sine of 40 now, sine of 40 over R, which that's this side here. This is R. It's the opposite side, 40 over R. Our sine equals, right? And then we could take, we know this side here, we don't know this angle beta. We get our, yeah. We can say sine beta. Got too many ends there, huh? Sine beta over 150, okay? Now, we know this is 301 here. So we got sine of, okay, so we got 40 degrees, right? So sine of 40 over the opposite side, right? There's R. We already calculated R, which is 301. And I'll just go ahead and scratch that out so it's not confusing. We just only have one unknown now. So we got beta, sine beta equals 150. Sine beta is 150 times sine 40. Cross multiplying is all we're doing over 301. So beta equals the inverse sine of that expression. All right, so beta so we're going to get 150, okay, excuse me, 40 sine times 150 equals divided by 301 equals, and then we're going to do inverse sine of that, and that's roughly So if this is 18 degrees here, it doesn't look right. So we have, one more time, sine of 40 over r, that is right, and the sine of beta over 150. Oh, no wonder. This is the angle that here, 18, sorry, 18 degree, 18.68. My phone is acting up. Yeah, 18.68 degrees. All right, so we need to know what alpha is now. Remember, all the angles have to equal 180, right? So what is alpha now? If this is 18.68 and that's 40, plus 40 minus 180. And so alpha appears to be, I've got an issue with this problem. I'm going to get back with you. I promise. The magnitude is right, but my angle is not coming out to be right. So I'm going to look at this in more detail and get back. So go ahead and approach this problem, like up to this point, and I'm going to look at the second half of this problem. Okay. Sorry about that. I don't know what happened, but I'm going to look at that. I don't want to take the time now because I'm going to waste a lot of time on one problem. All right. So now I'm going to work some more problems from the back of this chapter 2. So this is problem 2-17B, and you have something that looks like this. This is 2 kips, and this is some angle 50 degrees, and we want to find the x and y component. So this is the vector. There's the magnitude. By the way, a kip is 1,000 pounds. So 2 kips is going to be 2,000 pounds, and 2,000 pounds is a ton. And we have the angle that it makes. So we have the direction, and we have the angle it makes with the horizontal. So you simply make a right triangle out of this. So this is going to be P of x, and this is going to be P of y, and of course this is P. So we know what P is. Again, that's 2 kips. That's 2 kips. And we know this angle here is 50. Now, when you're trying to find the adjacent side of this triangle, so in other words, PX is going to equal 2 cosine the angle 50 degrees. That's going to give us this leg right here. That's going to give us that component. That's the x component. So 2 cosine 50 gives us this. Get the vertical leg here. Get the vertical leg, we have py equals 2 sine, sorry, you can't see that, 2 sine 50. All right, and this becomes 1.53 kips, and this becomes 1.29 kips. So again, when you're trying to get the horizontal leg of the horizontal component, P of x, it's going to be P cosine, because this is the adjacent leg. This is a leg opposite of the angle. So it's going to be P is going to x is going to be 1.53, right? And this is going to be 1.29. So 2 cosine 50 is 1.53 kips, and 2 sine 50. Now, what if you have some, so that's if you have an angle. But what if you have like a forced triangle like this? So you have a vector, which is 120, all right, and you have Mr. Morris, this looks different. Yep, this is a little bit different. You have a 3-4 triangle right there. That's a forced triangle. You don't have an angle. You could calculate it, but it's very easy to solve. You want to solve for the components of this. So we're going to solve for components of that vector. So in other words, what is this and what is this? This is going to be, we'll call this P again to make life simple for us. So P is equal to 120. So this is PY, and this is going to be PX. Mr. Morris, how do you solve that? Well, here you go. This is a 3-4-5 triangle. I know this because it's a special triangle. If you do the Pythagorean theorem, you'll see that the hypotenuse is 5. So to get the horizontal leg, you're going to take this 4 here and over 5. So PX now is equal to what the horizontal leg is, 4 divided by the hypotenuse times 120. That's the horizontal leg. And the vertical leg now, what is the vertical side? 3 over 5. You have to put it over the hypotenuse times 120. Okay, so this is equal to 96, and this is equal to 72. We'll just call it pounds. I don't remember what the units are. I didn't write that problem down. But anyway, again, you have a vector, which is 120. We'll call that P. And you see you have a forced triangle, 3, 4, 5. And to solve for the horizontal component, well, this is the 4. That's the horizontal side is 4 divided by the hypotenuse times 120. To get the vertical leg, you multiply by 3 over 5. Okay? And that's going to be in pounds. Each of those are in pounds. All right. So the last problem I want to work tonight from this chapter is problem 233. Problem 233. So problem 233. And basically it's an eye bolt. It looks like this. Okay. And you have these forces, it could be cables put on the eye bolt. So this is 4 kilonewtons here. This is 4. This is the vector, 4 kilonewtons, and it's 20 degrees from the vertical. And then you have another cable pulling here. This is 15 degrees. So you got 20 degrees, 15 degrees, and you have this vector here is 5 kilonewtons. And we have 3 kilonewtons here, pulling on it. And then again, this is 2 kilonewtons. So this is perfectly horizontal. Now, all these vectors that are at an angle with respect to the X and Y axis, you got 2 components for each one of those. You don't have 2 components for this one. You just have an X component. So what I did is I made up a table. This is the force, this is the X component, and this is the Y component. And we're going to have to go back to our math class here because I don't want you to get confused with the trig functions here. So for example, let's look at, and here's what I mean by this. This force here is 5 kilonewtons, right? Now to get the X component of that force, this would be the X component right here. That would be the X, and this would be the Y for that. So the X component now, don't let this mess you up because you're going to think it's a cosine It would be if you had this angle, but you don't have this angle. You don't have the angle adjacent. You have this angle here. So this is the adjacent angle now to the y-axis. So you're going to have, and it's going, the horizontal component for that vector is going in a negative x direction. So you have negative 5 sine 15 degrees. Okay, again, you have this vector, and this is the angle, right? So the sine would be this leg here, right? The sine would be this leg, which you transpose down here. So it's going the negative direction. So it's negative 5 sine 15. However, the vertical leg is going to be 5 cosine 15 degrees. All right. Now, we're going to add these up in a minute. And then the 4 kilonewtons, that's this vector right here. That's this vector. And the horizontal leg is this one, and the vertical leg component. So we have the x component and the y component for that force. You're going to have 4 sine 15. That's going to give you this, again, because it's this angle. So this is the adjacent side. This is the side opposite. So it's 4, oops, I said sine, it should be 20, sorry. Sine 20 and then 4 cosine 20 degrees. And both of those are positive. One more time, 4 sine 20 is this one, and 4 cosine 20 is this leg here. Okay. Now we have our 3 kilonewton force. Notice it's coming down, and then now this is our adjacent leg here. So we're going to use negative 3 cosine 30. That's this angle here. So negative 3 cosine 30. And then you're going to have a negative 3 sine, because again, it's going down. The component is going down. It's going to the left and it's going down. So both of those are negative. Sine 30. I'm sure I'm going to have some questions on this problem. Please feel free to contact me if you have some issues with it. And then we have the 2 kilonewton force. We just have an x component there only. So it's just 2 kilonewtons here and 0 in the y. See, we don't have a y component for this one. We're going to add these up. When you add these up, let me do this real quick. Sine times 5 maybe. So this first is going to equal, I'm going to calculate these now, 1.29 negative. This next one here is 20 sine times 4 equals 1.36. Okay, and then the next one is 30 cosine times 3 negative equals negative 2.59. We'll just round this up to 2.60. So that's these, and then plus 2. So when you add these together, you're going to get a negative, move this up here, a negative 0.53. That's a negative 0.53. Now we have to do this other side over here. I did this earlier, 5 cosine 15 degrees. I got 4.82. And then 4 cosine 20, I got 3.75. And then negative 3 sine 30, I got negative 1.5. And when I did my math there, I got, let's see, let me add this up real quick. Just check my numbers. 4.82 plus 3.75 plus 1.5 negative 7.07. All right, Mr. Morris, what do we do with these numbers? So we add up all the horizontal components, we add up all the vertical components. Now we have, these are the results of all the horizontal, negative 0.53, and 7.07 is the result of all the y components. So we're going to take these two numbers and make a right triangle. And if you don't mind, I'm just going to come up here and do it here. So we come over negative 0.53 going to the left, and we're going to go up this way, 7.07. So the result of all those forces acting on this eyeball is right here. You use the Pythagorean theorem here, so you're going to have 0.53 squared plus 7.07 squared, take the square root of that, equals R. Okay, so let's do the math here. 0.53 squared plus 7.07 squared equals y to the 0.5, and R equals 7.08. I think the answer in the back of your book is 7.11. It's off a little bit. It could be from rounding. And the angle now, this angle right here, we need to know this angle. So I'll just do this right here. The tangent of theta is 7.07 over 0.53. And if you take the inverse tangent of that, 7.07 over 0.53, sorry. I know it's hard to see, but theta equals inverse tangent 7.07 of 0.53. You're going to get an angle theta equals 85.7 degrees. All right, so let's review this, recap this problem. Again, this is problem 2-33. I drew the eye bolt and I applied all the forces to it. And I came down here and I found out, for each force, I found out the X and the Y components for each force. I said, be careful with your trig functions. Sometimes they flip on you, depending on what axis you're working with. So if you have trouble with that, I know that sometimes that's hard for students to see. Be careful of that. This is, again, right triangle trigonometry. And then you get the resultant of the horizontal components and the resultant, you just add them up of the y components, and then you draw a triangle, a right triangle based on those. So we had a negative 0.53, so it's going to the left, and then 7.07 is going up. That's positive. Take the Pythagorean theorem, you find the resultant. The resultant I got was 7.08. Again, I think in the back of the book, the 7.11, it could be from rounding, but it's interesting, like I did get the same angle as they did. They got 85.7 degrees. All right, I thank you very much. I know I threw a lot at you. I'm gonna post another video. What you need to do is you need to, I'm gonna have a specific instruction for you. You need to watch my videos, and I would encourage you also to watch Professor Young's videos. She's made some excellent videos, so please watch those as well. All right, we'll get through this together. I know some people worry about statics, but you're going to be fine, okay? So have a great night, great day, whenever you watch this, night or day. It's nighttime right now. It's actually 9:55 on Saturday night. I'm out in my garage making this video for you. So I hope it was helpful to you, these problems. Again, please call me if you have any questions or concerns. I thank you and have a good night.